Alright guys, welcome back to the stream. Today I'm going to be streaming, once again, Khan Academy, Algebra 2, finding the inverse of functions. So the first thing we have in finding the inverse function is a video over linear inverses of functions. Then we have quadratic, then quadratic example 2, radical, rational, and then we have a document. So we're going to start with the first video.
So we have f of x is equal to negative x plus 4, and it's f of x is graphed right here on our coordinate plane. Let's try to figure out what the inverse of f is. And to figure out the inverse, what I like to do is I set the variable y equal to f of x, or we could write that y is equal to negative x plus 4. Right now, we've solved for y in terms of x. To solve for the inverse, we do the opposite. We solve for x in terms of y. So let's subtract 4 from both sides. You get y minus 4 is equal to negative x. And then to solve for x, we can multiply both sides of this equation times negative 1. And so you get negative y plus 4 is equal to x. Or just because we're always used to writing the dependent variable on the left-hand side, we could rewrite this as x is equal to negative y plus 4. Or another way to write it is we could say that f inverse of y is equal to negative y plus 4. So this is the inverse function right here. And we've written it as a function of y. But we can just rename the y as x. So it's a function of x. So let's do that. So if we just rename this y as x, we get f inverse of x is equal to negative x plus 4. These two functions are identical. Here we just use y as the independent variable or as the input variable. Here we just use x, but they're identical functions. Now, just out of interest, let's graph the inverse function and see how it might relate to this one right over here. So if you look at it, it actually looks fairly identical. It's negative x plus 4. It's the exact same function. So let's see. If we have the y-intercept is 4, it's going to be the exact same thing. The function is its own inverse. Is its own inverse. So if we were to graph it, we would put it right on top of this. Right on top of this. And so there's a couple of ways to think about it. In the first inverse function video, I talked about how a function and their inverse, they are the reflection over the line y equals x. So where's the line y equals x here? Well, the line y equals x looks like this. Line y equals x looks like this. And negative x plus 4 is actually perpendicular to y is equal to x. So when you reflect it, you're just kind of flipping it over, but it's going to be the same line. It is its own reflection. And let's make sure that that actually makes sense. When we're dealing with, I guess, the standard function right there, if you input a 2, it gets mapped to a 2. If you input a 4, it gets mapped to 0. What happens if you go the other way? If you input a 2, well, 2 gets mapped to 2 either way, so that makes sense. For the regular function, 4 gets mapped to 0. For the inverse function, 0 gets mapped to 4. So it actually makes complete sense. Let's think about it another way. For the regular function, let me write it explicitly down. This might be obvious to you, but just in case it's not, it might be helpful. So f of, let's pick f of 5. F of 5 is equal to negative 1. Or we could say the function f maps us from 5 to negative 1. Now, what does f inverse do? What's f inverse? F inverse of negative 1. F inverse of negative 1 is 5, is equal to 5. Or we could say that f maps us from negative 1 to 5. So once again, if you think about kind of the sets, there are domains in our ranges. So let's say that this is the domain of f. This is the range of f. F will take us from 5 to negative 1. That's what the function f does. And we see that f inverse takes us back from negative 1 to 5. F inverse takes us back from negative 1 to 5, just like it's supposed to do. Let's do one more of these. So here I have g of x is equal to negative 2x minus 1. So just like the last problem, I like to just set y equal to this. So we say y is equal to g of x, which is equal to negative 2x minus 1. Now we just solve for x. y plus 1 is equal to negative 2x. Just added 1 to both sides. Now we can divide both sides of this equation by negative 2. And so you get negative y over 2 minus 1 half is equal to x. Or we could write x is equal to negative y over 2 minus 1 half. Or we could write f inverse as a function of y is equal to negative y over 2 minus 1 half. Or we could just rename y as x. And we could say that f inverse of, oh, let me be careful here. That shouldn't be an f. The original function was g, so let me be clear there. That is g inverse of y. G inverse of y is equal to negative y over 2 minus 1 half. This we started with the g of x, not an f of x. Make sure we get our notation right. Or we could just rename the y and say g inverse of x is equal to negative x over 2 minus 1 half. Now let's graph it. Its y-intercept is negative 1 half, so it's right over there. And it has a slope of negative 1 half. It has a slope of negative 1 half. So let's see, if we start at negative 1 half, if we move over to 1 in the positive direction, we'll go down half. If we move over 1 again, we'll go down half again. If we move back, so we'll go like that. So the line, I'll try my best to draw it, will look something like that. And it'll just keep going. So it'll look something like that. It'll keep going in both directions. And now let's see if this really is a reflection over y equals x. Y equals x looks like that. And you can see they are reflections. If you reflect this guy, if you reflect this blue line, it becomes this orange line. But the general idea, you literally just, the function is originally expressed, is solved for y in terms of x. You just do some algebra, solve for x in terms of y. And that's essentially your inverse function as a function of y, but then you can rename it as a function of x.
Alright, so now we're going to watch the video over quadratic inverses.
We've got the function f of x is equal to x plus 2 squared plus 1. And we've constrained our domain that x has to be greater than or equal to negative 2. That's where we've defined our function. And we want to find its inverse. And I'll leave you to think about why we had to constrain it to x being greater than or equal to negative 2. Why it wouldn't have been possible to find the inverse if we had just left it as the full parabola. Maybe I'll make a future video about that. But let's just figure out the inverse here. So like we've said in the first video, in the introduction to inverses, we're trying to find a mapping. Or if we were to say that y is equal to x plus 2 squared plus 1, this is the function. You give me an x and it maps to y. We want to go the other way. We want to give you a y and then map it to an x. So what we do is we essentially just solve for x in terms of y. So let's do that one step at a time. So the first thing to do, we can subtract 1 from both sides of this equation. Y minus 1 is equal to x plus 2 squared. And now to solve here, you might want to take the square root, and that actually will be the correct thing to do. But it's very important to think about whether you're going to take the positive or the negative square root at this step. So we've constrained our domain to x is greater than or equal to negative 2. So this value right here, x plus 2, if x is always greater than or equal to negative 2, x plus 2 will always be greater than or equal to 0. So this expression right here, this right here is positive. This is positive. So we have a positive squared. So if we really want to get to the x plus 2 in the appropriate domain, we want to take the positive square root. And in the next video or the video after that, we'll show an example where you want to take the negative square root. So we're going to take the positive square root, or just the principal root, which is just the square root sign, of both sides. So you get the square root of y minus 1 is equal to x plus 2. And one thing I should have remembered to do is from the beginning we had a constraint on x. We had for x is greater than or equal to negative 2. But what constraint could we have on y? If you look at the graph right here, x is greater than or equal to negative 2. But what's y? What is the range of y values that we can get here? Well, if you just look at the graph, y will always be greater than or equal to 1. And that just comes from the fact that this term right here is always going to be greater than or equal to 0. So the minimum value that the function can take on is 1. So we could say for x is greater than or equal to negative 2. And we could add that y is always going to be greater than or equal to 1. Right? Y is always greater than or equal to 1. The function is always greater than or equal to that right there, to 1. And the reason why I want to write it at this stage is because, later on we're going to swap the x's and y's. So let's just leave that there. So here we haven't explicitly solved for x and y, but we can write for y is greater than or equal to 1. This is going to be the domain for our inverse, so to speak. And so here we can keep it for y is greater than or equal to 1. This y constraint is going to matter more because over here, the function, the domain is x. But for the inverse, the domain is going to be the y value. And then let's see, we have the square root of y minus 1 is equal to x plus 2. Now we can subtract 2 from both sides. We get the square root of y minus 1 minus 2 is equal to x for y is greater than or equal to 1. And so we've solved for x in terms of y. Or we could say let me just write it the other way. We could say x is equal to, I'm just swapping this, x is equal to the square root of y minus 1 minus 2 for y is greater than or equal to 1. So you see now, the way we've written it now, y is the input into the function, which is going to be the inverse of that function. X is the output. X is now the range. So we could even rewrite this as f inverse of y, that's what x is equal to the square root of y minus 1 minus 2 for y is greater than or equal to 1. And this is the inverse function. We could say this is our answer, but many times people want the answer in terms of x. And we know we could put anything in here. If we put an a here, we could take f inverse of a, and it'll become the square root of a minus 1 minus 2 for, well, assuming a is greater than or equal to 1. But we could put an x in here. So we can just rename the y for x. So we could just do a renaming here. So we could just rename y for x. And then we would get, let me scroll down a little bit, we would get f inverse of x. And I'll highlight it here just to show you we're renaming y with x. You can rename it with anything, really. Is equal to the square root of x minus 1 of x minus 1 minus 2 for, we have to rename this too, for x being greater than or equal to 1. And so we now have our inverse function as a function of x. And if we were to graph it, let's try our best to graph it. Maybe the easiest thing to do is to draw some points here. So the smallest value x can take on is 1. If you put a 1 here, you get a 0 here. So the point 1, negative 2 is on our inverse graph. So 1, negative 2 is right there. And then if we go to 2, let's see, 2 minus 1 is 1. The principal root of that is 1 minus 2, so it's negative 1. So the point 2, negative 1 is right there. And let's think about, let's see, if we did 5, I'm trying to take perfect squares. 5 minus 1 is 4 minus 2. So the point 5, 2 is, let me make sure. Oh, 5 minus 1 is 4. Square root is 2. Minus 2 is 0. So the point 5, 0 is here. And so the inverse graph, it's only defined for x greater than or equal to negative 1. So the inverse graph is going to look something like this. It's going to look something like, I started off well and it got messy. So let's see, it's going to look something like that, just like that. And just like we saw in the introduction to function inverses, these are mirror images around the line y equal x. Let me graph y equal x. Y equals x. Y equals x is that line right there. Notice they're mirror images around that line. Over here, we map the value 0 to 5, right? If x is 0, it gets mapped to 5. Here we go the other way. We're mapping 5 to the value 0. So that's why they're mirror images. We're essentially swapped the x and y.
All right, now we're going to watch the one on finding inverse functions, quadratic example 2.
We have the function f of x is equal to x minus 1 squared minus 2. And they've constrained the domain to x being less than or equal to 1. So we have the left half of a parabola right here. And they constrained it so that it's not a full u parabola. And I'll let you think about why that would make finding the inverse difficult. But let's try to find the inverse here. And a good place to start, let's just set y being equal to f of x. So we could say y is equal to f of x, or we could just write that y is equal to x minus 1 squared minus 2. We know it's 4, x is less than or equal to 1. But right now we have y solved for in terms of x, or we've solved for y. To find the inverse, we're going to want to solve for x in terms of y. And we're going to constrain y similarly. And we can look at the graph and we can say, well, in this graph right here, this is defined for y being greater than or equal to negative 2. So we can maybe put in parentheses y being greater than or equal to negative 2. Because this is going to be, right now this is our range, but when we swap the x's and y's, this is going to be our domain. So let's just keep that in parentheses right there. So let's solve for x. So that's all you have to do to find the inverse. Solve for x, and make sure you keep track of the domains and the ranges. So let's see. If we could add 2 to both sides of this equation, we get y plus 2 is equal to x minus 1 squared, right? Minus 2 plus 2, so those cancel out. And then I'm just going to switch to the y constraint, because now it's not clear what whether y is the domain of the range or the x is the domain of the range. But we know by the end of this problem, y is going to be the domain. So let's just swap this here. So for y is greater than or equal to negative 2. And we could also say in parentheses x is less than 1. We haven't solved explicitly for either one, so we'll keep both of them around right now. Now, to solve for y, or solve for x, you might be tempted to just take the square root of both sides here, and you wouldn't be completely wrong. But we have to be very, very, very careful here. And this might not be something that you've ever seen before. So this is an interesting point here. We want to we want the right side to just be x minus 1. That's our goal here in taking the square root of both sides. We want to just have an x minus 1 over there. Now, is x minus 1 a positive or a negative number? Well, we've constrained our x's to being less than 1. So we're dealing only the situation where x is less than or equal to 1. So if x is less than or equal to 1, this is negative. This is negative. So we want to take the negative square root. Let me just be very clear here. If I take negative 3, if I take negative 3 and I were to square it, that is equal to 9. Now, if we take the square root of 9, if we take the square root, let's say we take the square root of both sides of this equation, and our goal is to get back to negative 3. If we take the positive square root, if we just take the principal root of both sides of that, we would get 3 is equal to 3. But that's not our goal. We want to get back to negative 3. So we want to take the negative square root of our squared. So because this expression is negative and we want to get back to this expression, we want to get back to this x minus 1, we need to take the negative square root of both sides. You can always, every perfect square has a positive or a negative root. The principal root is a positive root. But here we want to take the negative root because this expression right here is going to be negative, and that's what we want to solve for. So let's take the negative root of both sides. So you get the negative square root of y plus 2 is equal to, and I'll just write this extra step here just so you realize what we're doing, is equal to the negative square root of x minus 1 squared for y is greater than or equal to negative 2 and x is less than or equal to 1. That's why the whole reason we're going to take the negative square root there. And then this expression right here, so let me just write the left again. Negative square root of y plus 2 is equal to the negative square root of x minus 1 squared is just going to be x minus 1. Is just going to be x minus 1. X minus 1 squared is some positive quantity. The negative root is the negative number that you have to square to get it, to get x minus 1 squared. So that just becomes x minus 1. Hopefully that doesn't confuse you too much. We just want to get rid of this squared sign. Make sure we want to get the negative version. We don't want the positive version, which would have been 1 minus x. Don't want to confuse you. So here, we now just have to solve for x. Add 1, and let me write 4. Y is greater than or equal to negative 2. Add 1 to both sides. you get negative square root of y plus 2 plus 1 is equal to x for y is greater than or equal to negative 2. Or if we want to rewrite it, we could say that x is equal to the negative square root of y plus 2 plus 1 for y is greater than or equal to negative 2. Or if we want to write it in terms as an inverse function of y, we could say, f inverse of y is equal to this, or f inverse of y is equal to the negative square root of y plus 2 plus 1 for y is greater than or equal to negative 2. And now, if we wanted this in terms of x, if we just want to rename y as x, we just replace the y's with x's. So we could write f inverse of x, and I'm just renaming the y here, is equal to the negative square root of x plus 2 plus 1 for, I'm just renaming the y, for x is greater than or equal to negative 2. And if we were to graph this, let's see, if we started x is equal to negative 2, this is 0. So the point negative 2, 1 is going to be on our graph. So negative 2, 1 is going to be on our graph. Let's see, if we go to negative 1, negative 1, this would become a negative 1. Negative 1, 0 is on our graph. Negative 1, 0 is on our graph. And then let's see, if we were to put x is equal to 2 here, so x is equal to 2 is 4. 4 square root, principal root is 2, but it becomes a negative 2. So it becomes 2, negative 1. So that's on our graph right there. So the graph is going to look something like this of f inverse. It's going to look something like that right there. And as you can see, it is a reflection of our original f of x along the line y is equal to x. Along the line y is equal to x. Because we've essentially just swapped the x and the y. This is about as hard of an inverse problem that I expect you to see, especially in a pre-calculus class, because it really is tricky to realize that you have to take the negative square root here, because the way our domain was constrained, this value right here is going to be negative. So to solve for it, you want to have the negative square root.
Alright, and now we have 2 more videos.
So we're told that h of x is equal to the negative cube root of 3x minus 6 plus 12. And what we want to figure out is, what is the inverse of h? So what is h inverse of x going to be equal to? And like always, pause the video and see if you can figure it out. Well, in previous videos, we've emphasized that what an inverse does is a function will map from a domain to a range, and you could think of the inverse as mapping back from that point in the range to where you started from. So one way to think about it is we want to come up with an expression that unwinds whatever this does. So if we say that y is equal to h of x, well, we could say that y is equal to the negative of the cube root of 3x minus 6 plus 12. This gives us our y, and you can think of y as a member of the range in terms of what our input is, in terms of a member of the domain. But we want to go the other way around. So what we could do is we could try to solve for x. If we solve for x, we're going to have some expression that's a function of y. We're going to have that being equal to x. And so that would be the inverse mapping. Another way you could do that is that you could just swap x and y and then solve for y. But that's a little bit less intuitive that this is actually the inverse. So actually, let's just solve for x here. So the first thing that we might want to do is let's isolate this cube root on, let's say, the right-hand side. So let's subtract 12 from both sides. And we would get y minus 12 is equal to the cube root of, it's actually the negative cube root. Don't want to lose track of that. Negative cube root of 3x minus 6. And then we subtracted 12 from both sides. So that 12 is now gone. And now what we could do, well, we could multiply both sides by a negative 1. That might just get rid of this negative here. So we multiply both sides by a negative 1, and then we multiply this times a negative 1. On the left-hand side, well, that's the same thing as 12 minus y. And on the right-hand side, we're going to get the cube root of 3x minus 6. And now, and this is going to be a little bit algebraically hairy, we want to cube both sides. So let's do that. So let's cube both sides. And actually, it doesn't get that algebraically hairy because I don't have to figure out what this, I don't have to expand it. I can just leave it as 12 minus y cubed. And so if we cube both sides, on the left-hand side, we're just left with 12 minus y cubed. And on the right-hand side, well, you take the cube of the cube root, you're just going to be left with what you originally had under the cube root sign, I guess you could say. And now we want to solve for x. Let's add 6 to both sides. So we're going to get 12 minus y cubed plus 6 is equal to 3x. Now we could divide both sides by 3, and we're all done. Divide both sides by 3, and we get x is equal to 12 minus y to the third power plus 6 over 3. And so this, if you have a member of the range, one way to think about it, if you have a member of the range y, this is going to map it back to the x that would have gotten you to that member of the range. So this is the inverse function. So we could write h inverse of y is equal to this business, 12 minus y cubed plus 6 over 3. And like we said in previous videos, this choice of just calling y the input, well, it could be anything. We could call that star. We could say h inverse of star, and we're just naming our input star is equal to 12 minus star cubed plus 6 over 3. Or if we just want to call the input x, we could just say h inverse of x. And once again, this is just what we're calling the input is equal to 12 minus x to the third plus 6 over 3. Might be a little bit confusing because now, in theory, x could be considered a member of the range, and we're mapping back to a member of the domain. But either way, we can call the input function to a function practically anything. But there you have it. That is our inverse function that essentially unwinds what our original function does.
All right, and now we have one last video, and then we will.
So we're told that g of x is equal to 2x minus 1 over x plus 3. Based on this, pause the video and see if you can figure out what the inverse of g is. G inverse of x. What is that going to be equal to? All right, I'm assuming you've had a go at it. And just as a little bit of a reminder of what we're talking about when we're talking about inverse of functions or inverses of functions, if that's the domain, the set of all inputs that we can input into g, so that's the domain. And if we consider the range to be the set of outputs, so that is the range. For a given input, so for a member of the domain x, the function g, let me do it in that color, the function g will map it to a point, let me do g in yellow. It will map it to a member of the range. So if this is x, this value right over here we would consider to be g of x. That's what the function g does. Now, the inverse function goes the other way. You start with a member of the range, and you go back to a member of the domain. That's what g inverse does. And so there's a couple of ways to think about it. If we were to say, look, let's just set y is equal to g of x. So we could just call that point y as well. So this says, this expression here lets us know, okay, if we have an x, this is what we do. We multiply 2 times it, we subtract 1 divided by x plus 3, and then that tells us what the associated g of x or what the associated y is. But what if we're given the y or the g of x? How do we get x? Well, we could just solve for x. So let's do that. If we said that y is equal to 2x minus 1 over x plus 3, let's solve for x so that we know that for any y we get, what x the corresponding x will get. So how do we do that? Well, we can multiply both sides times x plus 3. So if we do that, we're going to get y. We're going to get y times x plus 3. X plus 3 is equal to 2x minus 1. All I did is multiplied both sides times x plus 3. X plus 3, and I multiplied x plus 3 on that side as well. The x plus 3 cancels out with the x plus 3. And then, let's see what we could do now. Well, we could distribute the y. And I'll switch now to a different color because that's going to get complicated if I keep trying to separate the y's in a different color. So we're going to get y times x, yx plus 3y is equal to 2x minus 1. And remember, we are now trying to solve for x. So we could collect all of the x terms on one side of this equation and then all of the non-x involved terms on the other side. So let's get all of our x terms on the left-hand side and all of our non-x terms on the right-hand side. So I want to get rid of this. This doesn't involve an x, so let me subtract 3y here. And so I'll subtract 3y from this side, minus 3y. And we want to get rid of this from the right-hand side, so minus 2x. So we could put it right over here, minus 2x. And so we are going to get, let me scroll down a little bit. So, whoops, sorry for that. So this is going to be yx minus 2x is going to be y minus 2 times x. These cancel out, which is their goal, is equal to 2x minus 2x. Those cancel out, which was the goal. And then you have 1 minus 3y. 1 minus 3y. And now to solve for x, you just divide both sides by y minus 2. Y minus 2. And we're going to get x is equal to 1 minus 3y over y minus 2. So one way you could think about it is you could say, well, x is equal to this expression is equal to the inverse function as a function of y. You give me a y, you give me a y that's sitting in this range. I can input it into this function definition here, and I can give you the corresponding x. I can give you the corresponding x. Now, we didn't ask for g inverse of y. We asked for g inverse of x. But the important thing to remember is this variable that we use inside of functions right over here. They're chosen somewhat arbitrarily. They just say, okay, I'm going to call the input y, and if you're going to call the input y, well, this is how I would give you the output. But we could call the input a, and that would be 1 minus 3a over a minus 2. Or we could even call the input, so let me make this clear. So we have g inverse of y. Actually, since I did it in blue up here, let me write that in blue as well. So if we did g inverse of y, I'm just rewriting what we already have, is equal to 1 minus 3y over y minus 2. This choice of variable is arbitrary. We could say g inverse of smiley face is equal to 1 minus 3 times smiley face over smiley face minus 2. Or if we wanted if we want to call the input x, we would just write g inverse of x is equal to 1 minus 3x over x minus 2. And we'd be done. Now I really want to point out, you might say, well, this is confusing because now we're calling the input to this x. Well, we normally associate y with the variables in the range. That's true, but you have to remember these variables, they're just labels that we apply to things so that we can keep track of them. But they're just what we call the input. So we could call the input into the inverse function. We could call it x, smiley face, y, a, b, c, d, whatever we want. So they want it in terms of g inverse of x. So we're going to define the input as x, whatever we input into it as x. And so this is going to be the expression that maps back. Now another way that you could have done this, because if you think about what just happened here, if we said now that y is equal to g inverse, we've essentially swapped the x and y variables. So one way to solve these is you can start where we started, right over there, and then you swap the x's and the y's, which is essentially what we did at the last step, the way I did it, and then you solve for y after the swap, and you would get to this same result, and you could say y is equal to g inverse. So I encourage you to try either way.
All right, and now we move on to the article. So here we go. Inverse functions, in the most general sense, are functions that reverse each other. For example, if f takes a to b, then the inverse, f inverse, must take b to a. A, as you can see in this graph, you take a, put it into f, you get b, put b into f inverse, and you get a. Or in other words, I'm not quite sure how to read that. In this article, we learn how to find the formula of the inverse functions when we have a formula of the original function. Before we start, in this lesson, we will find the inverse functions of f of x equals 3x plus 2. Before we do that, let's first think about how we would find f inverse of 8. To find f inverse of 8, we need to find the input of f that corresponds with an output of 8. This is because if f inverse 8 equals x, then by definition, f of x equals 8. So let's fix f of x to 8. Then we subtract 2. So we have 6 equals 3x divided by 3. And we have, so f of 2 equals 8, which means f inverse 8 equals 2. Finding inverse functions. We can generalize what we did above to find f inverse y for any y. Why did we use y here? Because we must choose something different than x that is already involved in the function. To find f inverse y, we can find the input of f that corresponds with an output of y. That is because if f inverse y equals x, then by definition, f of x equals y. F of x equals 3x plus 2, and then we can fix f of x to y. Y equals 3x plus 2, y minus 2 equals 3x, y minus 2 over 3 equals x. So f inverse y equals y minus 2 over 3. Since the choice of the variable is arbitrary, we can write this as f inverse x equals x minus 2 over 3. And are there any other ways to do this? Because inverse functions reverse the inputs and outputs, another way to find f inverse is by switching x and y initially, then solving for y to write the inverse in function form. So we switch x and y, then we subtract 2 from both sides, divide both sides by 3. So f inverse x equals x minus 2 plus divided by 3. Notice the similarities among the two methods. In each case, the equation is solved for the variable which is not isolated. It's solved for this variable here, that one, and in that one, and up here it's solved for y. The main difference involves when variables are reversed. The first method does this at the end, while the second method does this initially. Alright, now we're going to check our understandings for linear functions. So find the inverse of g of x equals 2x minus 5. So what we're going to want to do, alright, so we got to take g of x and we'll replace it with y. So we'll replace it with y. Y equals 2x minus 5. We'll add 5 to both sides. Y plus 5 equals 2x. And then we'll divide by 2 on both sides. Y plus 5 over 2 equals x. So g inverse of x should be y plus 5 over 2. And we got it wrong. So we'll see what we did wrong. To start, replace g of x with y, then solve for x. So we solve for x to get x on its own, then replace x with g inverse of y. Since the choice of variable is arbitrary, we can now switch y to x. So now we want to switch this y to x, because that's what was right there, and we'll check, and we got it right. Alright, now we have a cubic function. Find the inverse of h of x. So Here we go. So we'll replace with y equals x cubed plus 2. And we subtract 2 from both sides. Minus 2 equals x cubed. Then we want to take the cube root. X. There we go. And that should be our answer. So we want the cubed root y minus 2. But, once again, almost did the same exact mistake we did last time, is we want to change this back to the original variable, which is x. There we go. Now we have another cube root. Now we have a cube root function. So I'm going to clear the thing, and then now, there we go. Find the inverse of f of x equals 4 times cubed root of x. So we'll replace with y equals 4 times cubed root of x. And then we'll divide both sides by 4. Y over 4 equals cubed root of x. And then we will cube both sides. So it'd be y over 4 cubed equals x. But, once again, almost made the same exact mistake a third time. We want to replace it with x, so with that, and then we replace this other side with h inverse of x. Alright. So we're going to plug in the answer we got, x over 4 cubed. And we got it right. Now we're going to move on to rational functions. Alright, so find the inverse of g of x equals x minus 3 over x minus 2. So replace with y equals x minus 3 over x minus 2. We'll multiply both sides by x minus 2. Y times x minus 2. So we have 2y negative 2y plus xy equals x minus 3. We can divide both sides by x. And we'll get negative 2y. I'm not sure if I'm doing this right, plus y. So that'd be negative y equals negative 3. There's no way that's right. Alright, I need help. It's okay to need help. Alright, and so first we want to replace g of x with y. And then we multiply both sides by x minus 2. We did that. Then we want to distribute. We did that. Group terms with x on one side. We did not do that, so that's where we went wrong. There we go. So we want to get this x we'll move this y over here, and this x over here. Is that what they did here? Yeah. Then divide both sides by y minus 1. Divide this by y minus 1 and divide this by y minus 1. We will get we need to factor out an x over here. So it'd be 2. So as you can see, they factored out an x here. They divided both sides by y minus 1. They replaced x with g inverse y. And since the choice variable is arbitrary, we now switch y to x to write the inverse in terms of x. So this would be our answer, 2x minus 3. 2x minus 3 over x minus 1, x minus 1. And we'll check. All right. Now we have our challenge problems. Match each function with the type of its inverse. So this one is a square root. So that would be quadratic. This one is cubed, so this one would be cube root. And this one is rational, so it goes with rational and linear with linear. And we'll check. And we got it right. So now we're going to go do 4 practice questions. And then that'll be it for today. So what is the inverse function of h of x equals x to the 5th plus 6? So here we go. There we go. All right. So replace h of x with y equals x to the 5th plus, that was not a plus sign, plus 6. So we'll subtract both sides by 6. Y minus 6 equals x to the 5th. And then we will take the 5 root of both sides. Alright, and then we'll just plug in y minus 6. And this will just equal x. We'll replace the x, and then replace the x with h inverse of x. And then we'll replace the y over here with x. Because it doesn't matter what the variable is, and it will fit with the rest of the equation. So it'd be no, that's not it. Can we change this number? Oh, yes, we can. Okay. There we go. And then we're going to plug in y minus 6. Check. And we got it wrong. So let's see if we can find out where we went wrong. And then we will, and I already know. Once again, simple mistake. Place the y with an x. There we go. Alright, so what is the inverse function f of x equals negative 6x minus 7? We'll open up a new file, don't save. Alright, so we'll replace with y equals negative 6x minus 7. We'll add 7, y plus 7 equals negative 6x. We'll divide by negative 6. Divide by negative 6. So just be x of y plus 7 over negative 6. We can replace the y with an x, and we'll replace this x over here with f inverse of x. So this is going to be x plus 7 and negative 6. There we go. Next question. What is the inverse function of g of x equals negative x minus 2 over x plus 4? So we're going to clear this. We're going to replace with y. Y equals negative x minus 2 over x plus 4. We're going to multiply by x plus 4. Y of x plus 4x, and we'll just distribute in our head, equals negative x minus 2. What I did here is I multiplied the y times the x plus 4 and distributed in my head, so we could sort of like skip writing that step. We want to move all the x and I messed up too when I did that. All right, we're gonna get rid of that, and then this should be a y here. And then we're going to move this x over here. So it'd be y x plus x, because it's a negative x on that side. And we're going to add it. We're going to move it over. Equals, and we're going to move this 4y over to the other side. Negative 4y minus 2. Negative 4y minus 2. There we go. And so we have y of x, yx plus x equals negative 4 y minus 2. And then we'll take out an x here. X. And then we'll divide by y plus 1. So it'll be x equals negative 4y minus 2 over y plus 1. And that should be our answer, except we're going to replace these y's with x's. Can't forget to do that again. So we have negative 4. Actually, it's on one of these. Negative 4 x minus 2 over x plus 1. X plus 1. And we got it wrong. So we're going to get help. Let's start by replacing g of x with y, and we'll see what we did wrong. We'll follow along. We did that. We had y So if function contains a point a, b, then the inverse is ba. So if we swap the position x and y in the equation, we get the inverse relationship. So in this one, we should swap x and y. it'll give us the expression negative y minus 2 over y plus 4. Then they multiplied by y, distributed the x, moved all the y equations to one side. So that's kind of what we did with x. Yx, yeah. And then they had negative 1 and negative x, and then 4y plus 2. So we had problems with positives and negatives here. So plus it wasn't plus. Oh yeah. So it was negative 1 minus x, and then it was a positive 4x plus 2. There we go. All right, the inverse of the function h of x equals the 5 root of 6x minus 12, all that plus 1. Here we go. Replace with y equals 5 root of 6x minus 12 plus 1. So we're going to move the 1 to the other side. That's going to be y minus 1 equals 5. And then the this thing, 6y minus 12. And then we're going to do the times to the 5th. Alright, so it's going to be y minus 1 to the 5th equals 6x minus 12. So now we're going to add the 12 to the other side, so it's going to be y minus 1 to the 5th plus 12 equals 6x. We're going to divide by 6 here, and that's going to be... That's going to be 2, and y minus 1 to the 5th over 6. And we can work out this y minus 1 to the 5th. Y to the 5th minus 1. That's one straight line right there. Just look at how straight that line is. Alright. Because negative 1 times negative 1 is positive 1, times negative 1 is negative 1, times negative 1 is positive 1, times negative 1 is negative 1, and that's going to be over 6. It's going to be 2 minus x. So, our answer here is hopefully 2. Y to the 5th minus 1 over 6. And we got it wrong again. So we'll see what we did wrong. First, start by replacing with y. They switch the x and the y. We don't have to. We can switch it at the end. So it'd be plus 1. Alright, so we did minus 1 here. Yep. And then they did to the 5th. Yep. Plus 12 times 1/6. I mean, yeah. So they did 1/6 x minus 1 to the 5th plus 2. And that is basically the same answer we had, just worded differently. So it's 1/6 times x minus 1 to the 5th plus 2. And there we go. Well, that's all for today. Thanks for watching. Hope you guys liked. It was almost exactly an hour long. And I'm going to end it here.